All right, from the top, we've got, I think, 21 exercises in this chapter. Some are easy, some are less easy. First one's an easy one. This company needs some new equipment and they have multiple alternatives. It says one or more alternatives either meet or exceed the minimum expectations. So what type of decision should they make for their company? If they've got, actually that's kind of weird, one or more. Okay, let's just say they've got multiple alternatives that exceed expectations. So what type of decision would they make? In other words, if some of the options went through the screening process and made it through, so they weren't screened out, and they now have to narrow it down, what sort of decision are they making? Remember, beginning of the chapter, we had the, what's that? Preference. Exactly. Thank you, Joseph. So yes, at this point, because they've got multiple options that made it through the screening process, it's a matter of the preference of which one they prefer. Right? So it would be a preference decision. All right, next question. Give a current external factor that may currently impact or cause instability of capital spending, either here or abroad. So what the question is asking for, obviously in this chapter, we're using different types of analysis to compare different investment options for capital. But what other external factors outside of the company might influence our decisions? If you think back to when you took Introduction to Business and you learned about the external environment of business, there are economic factors. In fact, I'll write some of these down. So the economy, political factors, things like laws that get passed and whether or not a nation is at war. There are environmental factors, things like climate change. There are consumer preferences. All of these are external factors that could influence a company's decision on how it's going to invest its capital. For example, what was a company I just heard about that's, there's so many of them, but I was just reading today about a company that was laying off a whole bunch of people. Well, let's look at tech, for example. A lot of tech companies have been laying off a lot of people. And the general purpose for that is that coming out of the pandemic, they hired more people than they actually needed, especially because the economy was kind of booming coming out of the pandemic. And now they're realizing they've got more people than they need. So a lot of tech companies have been laying people off. That would be an example of something that might then impact their suppliers. If you sell chairs to Facebook and Facebook is cutting 10,000 employees, they're probably not going to be buying any chairs anytime soon, right? So if you're a chair company and you were just thinking about building a new factory to make more chairs to sell to Facebook, probably not a good time to be doing that, right? So these are just some of the different types of external factors that could influence our capital spending decisions. Does that make sense?
So did you put competitors actually?
Yeah, competitors. Good point. That's another aspect of the external environment that would definitely have an impact on capital spending. Number 3, a copy center considering the purchase of a new copy machine The investment cost is $150,000. Did we do this one?
No, we did number 5.
Okay. But it sounds a lot like one we did at the beginning. This was a printing company, but it's the same data. $150,000 investment divided by $20,000 annual net cash flow. And our payback period comes out to 7.5 years. Right? All we do is we take the investment
7 years.
divided by net cash flow, and we get the number of years to pay back. Okay, let's move on to a more challenging one. Here we have uneven cash flow. And we've got 2 different possible investments, A and B. So if we invest in machine A, it's going to cost $450,000. And it's going to generate this cash flow here. It's the same that we see up in the box. If we invest in machine B, it has the same cost, but the cash flow that it's going to generate for us is different. So since it's uneven cash flow, we need to break it down year by year. And this is not too hard. If we start with A, initially it was a $450,000 investment. We generate $190,000 of cash flow in the first year. So we could just subtract that $190,000. And now we need another $260,000 to pay back the investment, right? 450 minus 190 leaves us 260. In the next year, we get another 190,000 of cash flow. So how much do we need at this point to pay back our investment? $70,000, okay. The next year, we generate $60,000 of cash flow. So now we're down to $10,000. And then in this final year, we only need $10,000 more to reach that payback point, and we're expecting to generate $20,000 of cash flow. So what do we do then to figure out what portion of the year is where we're going to reach payback? So far, 3 years have gone by. We have $10,000 left to reach our payback point. What do we do? So all we have to do is just divide by our expected cash flow. 10,000 divided by 20,000 is half a year, right? 0.5. So that'll get us down to our original investment being completely paid off. If we compare that with option B, again, we start with 450,000, generate 150,000 in cash flow, so that brings us down to 300,000. Joseph?
Quick question for the cumulative column. Would that be 3.5 years then?
Exactly. So yeah, so the total is 3.5 years. Yeah, we could do that. Sure. Okay, so for option B, first year brings us down to 300,000. The next year, $180,000 of cash flow brings us down to $120,000 remaining. 60,000 of cash flow brings us down to 60,000 remaining. And so what do we do in this final year to figure out what portion of the year is where we're going to reach our payback period? We divide. Okay. We take our $60,000 remaining divided by the $70,000 of expected cash flow. we get, we'll call that 0.86. All right, so option A is going to take us 3.5 years. Option B will take 3.86 years. So by this analysis, if we don't consider any other factors, option A, which is also product A, is the better choice because it has the lowest number of years to pay back. Any questions on this exercise? Okay, we ready to move on? Oh, did we do 5? We did 5, and it was 7 years, right? Okay, we don't have to do it again then. And we'll move on to 6. So 6 is similar to what we just did with the uneven cash flow. The difference here is the outflow of cash is changing. So it's not just an initial investment. There's another investment in the second year. So that's going to make it a little more complex, but we can handle it. So for part A, we have to figure out what is the payback period for this investment. Okay, if in the first year we have to pay out $1.9 million, but we generate $100,000 of cash coming in, how much remains to pay back our initial investment? $1,800,000. Okay, right? So if it was originally 1.9 million, we subtract the 100,000 that came in, and we have 1.8 million remaining. Okay, then in the second year, there's another $550,000 that we have to pay out. So let's go ahead and add that. But then there's $200,000 that came in, so we'll subtract that. And that leaves us with $2,150,000 remaining. Fortunately, there are no more cash outflows. So from here on out, it's just a matter of subtracting the inflows. So in year 3, there's 360,000 coming in. We're down to 1,790,000. Then in year 4, there's $480,000 coming in. That's 1,310,000. In year 5, 510,000 coming in. We're now down to 800,000. In year 6, 600,000 coming in, so we're down to 200,000. And how do we get the portion of the year after that? Divide. So we take our $200,000 remaining, divide by the $590,000 of cash flow we're expecting in that next year. We'll round that off to 0.34. Okay, so the payback period is 6.34 years. That's our answer to A. B says, does our answer change if year 10's cash flow changes to 500,000? Would that change our payback period? Say no, Ms. Altman? No, you're right. You're right. Because we already paid it back in year 6.34, right? So what happens in 10 years is not relevant to the payback period. And so the answer to B is no. Okay, that wasn't too bad, right? 7, ARR. Initial investment is $300,000.
We did number 7.
We did 7 already? Oh, okay. Of
It was 25%.
course it was. Okay. All right, great. So 8, we put $250 in the bank for 5 years at 12%. Okay, and this is compounding. So calculate how much we have at the end of year 1 and year 2 and so on, all the way to the end of the 5th year. And so this is pretty easy to do with a calculator. How would I figure out how much money we'll have at the end of the first year if we're earning 12% interest?
250 times 12.
So we could do it that way, but we could also do 250 times 1.12, and that just saves us a step and shows that we'll have $280 after 1 year. Then what you can do, since we already said 250 times 1.12, I could just hit enter again, and it's going to add another 12%. So by the end of year 2, I'm up to 313.60. If I hit enter again, it's going to then multiply that by 1.12. So now we're up to 351.23. Hit enter again, 393.38. And the last time gets us to 440.59. Now we could have used the future value of $1 table. In fact, let's do that and see what we come up with. If we go to future value of a table, it was 5 years and it was 12%, right? 12%, 5 years, our factor is 1.762. Multiply that by the $250 investment. And we get $440.50. So it's almost the same. It's off by 9 cents. And that difference, again, is a rounding issue. Because again, this table that we're using here is only going 3 places after the decimal point. If the table went out further, we'd get a more accurate calculation. But it's, as you see, it's pretty close. All right, so it could be calculated either way with a pretty high degree of accuracy. I mean, you can't buy much with 9 cents anyways, right? Any questions on exercise 8? Okay. So let's go to exercise 9. Here it's asking if we invest $12,000 today, how much will we have in each of these 4 scenarios? So in other words, if our present value is $12,000, because that's what we're investing today, if we have a 9% interest rate over 10 years, what's that going to equal? What will be the future value versus these other 3 scenarios? So we could do this using the tables. In fact, that's what it says to do here. Which table would we use? Future value of $1 is correct. Okay, that's the one we're on here. So for example, we could say 9%, 10 years. Oh, we don't have 9%. So we'd have to find a different table. Or we can copy paste it into Excel, and solve it this way. If you're going to use a spreadsheet, you want to put your investment as a negative number because that's money you're investing. So think of it as money going out. And I'm just going to copy that down, cover all 4 scenarios. Okay. And let's go ahead and use our future value function to solve this for us. So again, we can use this function key over here. We are using future value, right? That's what we're trying to calculate is the future value. So I'm going to type in FV, click go. We see there is a future value function, so I'm going to select that one. It's asking me the rate. I could either type in 0.09 or I could click the box and then click that cell and then hit enter. NPER stands for number of periods. So again, I could either type in 10 or I could click the box and select the cell that has the number in it. Now, the next field here is payment. We're not going to use payment because that's only for annuities. So you can use the same future value function for annuities or for lump sum. If you're using annuities, you put the amount under payment. If you're using lump sum, you put it under PV for present value. So we're just going to skip payment since this is not an annuity. We're going to go to the box here for present value. And we'll click on our cell and hit enter. We don't need to put anything under type. Now when I click OK, it calculates for me. And what's really cool, since I didn't put in any specific numbers, remember instead I selected the cells in each case. If I copy this formula and paste it into these other cells, it's automatically going to calculate each of these for me. For example, this one is taking the rate from this cell and the time from this cell. This one is taking the rate from this cell and the time from that cell. So it's automatically adjusting based on the different information in each row. Makes it super easy. If that was too quick, don't worry, we're going to go through it again. I'm going to show you how it works in Google Sheets. But let's go ahead and take our answers and put them into our template here. Okay. For some reason, it doesn't like to divide it up, so I'm just going to have to do that manually. Oops. Okay, so these are our answers for exercise number 9. Now let's do it again, as I said, in Google Sheets. We're going to start with the same data. I'm going to take out these answers here. Oh, again, these have to be negative numbers. So the amount that's being invested has to be negative. A little shortcut in spreadsheets. If you want to fill in other cells that are below the cell you're in, you could just click and drag and then do Control D and it fills it in for you. Okay, so again, let's just go ahead and solve this from the beginning. So we need our future value function, right? We go to our function icon here. We go to financial, And then we look for future value. It wants the rate. Again, I could type in 0.09, but since I'm lazy, I'm just going to select the box here. Then when you want to do the next field, just enter a comma. And it automatically tells you what's next. Next is number of periods. I'm going to click on that cell. Comma. Payment amount, again, that's for annuity. So we're going to skip that. And the way we skip it is just enter another comma. And then present value is this field. Okay. So that's my formula. When I hit enter here, calculates it. Here's a nice thing about Google Sheets. It assumes I want to go ahead and just copy that formula down to the next 3 rows. And if I want to, I could just click on the check mark. There we go. Gave me the same answers I got in Excel. So, God bless you. Once you get used to using these formulas and functions in spreadsheets, it can save you a lot of time. Any questions about anything at this point? Okay. So we have the answers for exercise number 9. Did everybody get those answers? Right? All right, let's go on to number 10 then. It says we've been depositing money into an account yearly based on the following amounts, rates, and times. What is the value of the investment account at the end of that period? So in other words, what is the future value in each of these 4 scenarios? And this is kind of like what we just did. The difference is this is an annuity because the money is being invested every year. So again, I can just paste that into my spreadsheet. Maybe spread these out a little bit. Okay. So here's an issue. See how it says 15 years? The formula is not going to like that. It's not going to like the word years. So we have to just take it out. So we'll just put 15, 10, 5, and 2. And then once again, the amount of the investment has to be negative. Oops. Try that again. So I'm just going to add a minus sign before each of these amounts. Okay, and now we're ready to calculate. What function am I going to use to figure out the value of our investment at the end of the period? Can I use the same future value function I used before? Well, actually, we want to know what it's going to be worth at the end. So we are going to use future value. Right? Because that's what the question is. What is the value at the end of the period? If the question were, how much do we need to invest today to get a certain result, that would be a present value function. But in this case, we know the amount we're investing. We want to know what's the future value going to be. So we'll use the exact same present value function we used before. Just remember how it had the option of lump sum or annuity. Well, this time we're going to use the annuity option. So in Excel, we go to Insert Function, Future Value. Our rate is here. Number of periods is what? 15. Now, in this case, this is where we use payment. Because it's an annuity, it's an annual payment, whether it's a payment we're making or a payment we're receiving. Either way, it's a payment. So we are going to select the box and select our annual investment that we're paying. Enter. We're not going to put anything in PV because again, that's only for lump sum. And we don't need to put anything under type. So we're done. We can click OK. And then I can just copy that formula down to the other fields. And it's done. Nice and easy. So let's go ahead and do it in Google Sheets, since that is a little different than using Excel. I'm going to go back and copy this again. We'll go into Google Sheets. Yeah. Okay. Again, I have to take out the years. What else do I have to do to the data? Negatives, that's right. If you don't do that, it'll give you a negative answer. So by putting in a negative data amount for the beginning, it'll give you a positive answer, which is what we want. Okay, so then we can go to our function option up here. Remember in Excel, you click a link over here, but in Google Sheets, you have to go over here. You have to go down to financial. We're doing future value. So our rate is the 20%. What do I do to get to the next field? Comma, exactly. Number of periods, I click on the 15, comma. Payment amount is what? Okay, and then that's it. That's all we need. Enter, check. We're done. So I'll take these over to Word. Oops, I messed that up. Dude. Okay, let's try this again. Okay, those were the answers, right?
Yeah.
Yeah, okay. So for some reason, it likes to put them all in one cell. If anybody knows a trick to get it to not do that, you can tell me. But
I think if you highlight all the things first and then just.
oh, you might be right. You might be right. Let's try that. Try it that way. So if I go back and copy and then highlight the fields that I'm pasting into.
Yeah, highlight them in Control V.
Yes, that's it. That's it. Good point, Zay. Okay, much easier that way. All right, do we have time for one more? I think that might be kind of rushing it. So are there any questions about anything we've done so far? No? All right, well, that's it for today then. See you Thursday.